All right, welcome. This is the last talk of today until we have lightning talk madness. So our next speaker is Justin James with the iRODS Consortium. He's going to talk about new work that is almost ready, iRODS S3 resource plugin, Cashless, and Detached mode. There you go.
Okay, so first I'll start out with saying that this is the first slide you will see, the S3 Cacheless resource. It's cashless in the respect that there's not an iRODS cache associated with it, but there is a cache local file whenever files are uploaded and downloaded. So if you hear me say something about in the cache, don't get confused. I'm not talking about iRODS cache. I'll be talking about just local cache. Okay, so what is the Cashless S3 resource? First I'll kind of give you a brief summary of what the legacy operation is for the S3 resource. Most of this you already know, but just it'll help you kind of get an idea of what the Cashless is. So the legacy S3 plugin has to be used in conjunction with a compound resource and a cache resource. That has a couple of drawbacks. One of them is that requires that the Cashless S3, the S3 resource has to be attached to a specific resource server. The other one is that it requires that you have some cache cleanup policies, and that's a little bit of overhead, more than people want. So the original Cashless S3, the original S3 plugin basically implemented a few operations that the resources have to implement, but it didn't implement all of them, and therefore it needed the cache in front of it. So the only things it implemented were these 5 right here. The most important is the stage to cache and sync to archive. So any puts or gets that would go into iRODS, it would first be written into the iRODS cache resource, and then it would be staged to archive, and then on the other way, if it's not in the cache, it would be sync to cache first and then read from cache. So all the POSIX-like operations like seek and open, write, read, all of those were implemented in the cache resource itself, not in the S3 plugin. Okay, so the new Cashless S3 has 3 modes of operation. First off, I want to say this is a new mode to the existing plugin. We decided just architecturally not to create a brand new plugin for this. We just added a cashless mode to the existing plugin. So it has 3 different operating modes: archive attached, cashless attached, and cashless detached. And these are set in the context string with the host mode parameter. So it's configured just like all the other resources. You set the host mode to one of these 3. If the host mode is not set, then it goes to archive attached, which is the legacy operation. So that is the cache version of S3. So this will not break your existing deployments. Also notice archive detached is not a valid entry, basically because of what I said before. When you have a cache resource, it's basically pegged to a specific server. Okay, so I'll get into what these are. So the archive, so the first part of that configuration is archive and cashless. Archive is a legacy operation. It requires cache resource to provide POSIX semantics, and it must be attached to a specific iRODS server. Cashless S3 resource can be standalone, so you don't need any hierarchy in front of it or above it. May be detached from any specific iRODS server. Essentially every server could, if you chose to, could serve up the request for data object. And in the Cacheless one, the S3 plugin itself provides the POSIX semantics. And detached and attached, again, detached just means that it can, it's not pegged to a specific server. So any resource any resource server can serve up the request. Attached means that you are still, even though it's possible to have detached, you can peg it to a specific server. And that might be necessary if only certain servers have access to the backend S3. That could be your architecture where there's no connectivity because of firewalls or whatever from all of the iRODS servers to the S3 backend. Okay, so creating Cacheless S3 resource, it's basically almost identical to creating the cached S3 resource, except you have to add in the host mode parameter in the context string. So if you see at the very end here, you've got the host mode Cacheless attached, or it could be Cacheless detached. And of course, you could set the host mode for archive attached as well if you wanted to, but that's not required. Okay. So what do we have to do to implement the Cacheless S3 resource? We had the POSIX-like operations that were not implemented in the cache resource were having to be implemented. So, this is a subset of them, but open, read, write, close, seek, things like that. Okay, so how did we do this? First thing we did is we started with a project called S3FS. It's a Fuse plugin for S3. And so we basically, because there's a lot of operation overlap between some Fuse operations and POSIX operations, we thought starting with something that exists that's pretty solid would be a good starting point. So that was kind of a decision made at the beginning. But we had to validate that we were comfortable that S3FS was solid. So what we did was we took S3FS and pointed demo resource to an S3FS mount point, and then ran our suite of testing and verified that everything passed, except a few bundled test cases, which Jason knew was going to fail to begin with. That was expected. So that gave us, that convinced us that the S3FS was a good starting point for us. But of course, we're not creating, our goal wasn't to use Fuse as our, a Fuse mount as our back end. So we did have to make alterations to this. So the next step was to translate the Fuse operations to iRODS resource operations. So there are differences between Fuse and POSIX, and so it requires some updates. Of the many updates we had to do is we had to create our own file descriptors because everyone expected a file descriptor when you open a file, and we didn't have those available to us, so we created our own table of open file descriptors and mappings of the file descriptors to the open operations. We also had to store our own offset for each file descriptor so that anything like open seeks, writes, reads, everything can, I guess read wouldn't adjust offset, but write would adjust the offset. And so we had to adjust the offset as we did our POSIX-like operations. And that was a little bit of a learning experience for me because I would miss little things here and there. Like I may do a read and not know that the offset, or write and not know that the offset should get updated at the end of the write, and that would cause errors. But we worked through those pretty quickly. One problem with S3FS as a starting point was that it used a lot of global variables. If you just test it kind of in a single resource mode, didn't really cause any kind of problem. But once you put two S3 plugins under a replication node or or even some parallel puts and gets, that started to cause some problems every once in a while. So we had to, migrate a lot of that so that we could have multiple threads writing to the same, updating the same, writing to the same resource at the same time. The way we did that is I updated a lot of the global variables to thread local so that each thread would have its own copy. And also a lot of the configuration for the S3 configuration was stored in the plugin property map, which was read on each operation so that there was no conflict if you had multiple threads writing. Okay. The other thing, the most important thing, I guess the most important thing is to make sure it works. The second important thing is efficiency. What is our throughput? When we first did it, I created the plugin pretty fast because it was kind of a simple translation between views and POSIX. But then we noticed, the downloads and uploads are really bad, and we're like, how do we fix this? So one of the problems is iRODS, when it does parallel puts and gets, it asks for little chunks of data, right, at a time and in parallel. We can't just go out to S3 and write or read those little chunks every time iRODS asks for it. It's very inefficient for writes, and even for reads, it doesn't really take advantage of the S3 multi-part functionality. It kind of stops on that. Okay, this is about the reading, the download performance. S3FS did do read ahead, so that helped a lot with downloading. That allowed us to use the multi-part download somewhat, but it still wasn't good enough because iRODS would read, ask for like towards the end of the file, and then it might ask for something in the front, and we end up doing so many requests back to S3, and that's just not good. So the goal is, so our goal was to do a full file download to be reasonably close to the performance of the S3 CLI API. And, but we also wanted to quickly serve up small requests. So we didn't want to always just download the whole file every time someone wanted to read from it. So what we did was on the first read, we only get what the user requested. So if the user requests 1K bytes from a 30 gig file, they'll only get that 1K bytes. But once we have two parallel reads at the same time, then we assume that they're doing a parallel get, and we'll trigger a full file download. So once you're at that second thread asking for a chunk of data, we trigger the full file download, multi-part download, and then on each completion callback of the multi-part completion, each thread wakes up and checks to see if its part has been downloaded. If it has, it will return back to iRODS with its chunk of data. If it hasn't, it will wait until its part has been completed. So that kind of gave us the best of both worlds. We can, if someone just wants to read a little bit, from one part of the file to another part of the file and do several of those, they can do that quickly. But we also have good download performance. If you see this chart right here, I did some testing on this, comparing it to the S3 API, the CLI API. I made sure the MPU chunk and the MPU thread counts, the MPU chunk size and the thread count were the same for these tests, so we're comparing apples to apples. And this chart shows that we are pretty much right with the S3 CLI API. So we're pretty happy with that. And again, if the user requests a really small chunk, that returns really quickly. So we didn't break that. Okay, upload performance. This one was the one that was easier to solve, but it was the one that was really bad to begin with. The reason is when you upload part of a file in S3, it uploads the entire file, essentially. All right. So what you end up with is ON squared performance on an upload, and generally, I don't think people would want that. So this one was easy to solve, though. We know everyone who has a file open. So whenever there are multiple files open and people are writing, we just write to the cache file, and we don't flush that to S3 until the last close is done. And here's our performance. I was a little surprised to see that our performance is a little bit worse than the S3 CLI API. I'm going to look into this a little bit more in the next couple weeks and try to see if I can get these two graphs to be closer to the same. I think it's still linear, although it's kind of hard to tell by this. It looks like it might be, that slope might be increasing a little bit, but I'll run some more tests and see to make sure. I expect it to be a little bit slower just because we're writing to cache before flushing to S3, but I'd like to see it a little closer than that. Okay, so now we're going to demonstrate the S3 plugin. This probably is one of the more boring demonstrations you'll ever see, but just hang with me. Hopefully maybe it'll give you an idea of how easy it is to use. First thing, what do you need first before you set up an S3 resource? We need a key pair in a file that's exactly the same as the cache S3 key pair. The S3 plugin has to be installed on the server, of course, and you need to have a bucket in S3. So I've created a bucket named Justin Kyle James, iRODS 1, and created the resource. Now we'll create the resource, sorry. I'm on the right server. Okay, so just copy paste, and now we've got an S3 resource. Let's see. So if you see new S3 resource right there, it's just a standalone resource. It's not in any kind of tree or anything. Okay, so I'll create just a simple test file, and I'll put it into S3 just to show you it works. Okay, that worked. No, sorry. Alt down. Okay, so we put it into the S3 resource. It worked. Not very exciting. It's about a 20-byte file, so hey, we can write 20 bytes. That's great. To show you that it is an S3, we see it there. So we know we've written it, and I'll do a get. And we got the contents.
Yay.
Yeah. I told you it's the most boring demonstration you'll ever see. Like, why is this guy showing me this? I'll do a move and just show you that it is renamed in S3.
I move, need an I. You missed the I.
Oh, sorry. I copied the wrong thing, didn't I? Well, that's better than it not working, right? Okay, so we got the new S3. And we see it's a new location. And we'll remove it just to show that it's gone. And the file's up there. Okay, so it all worked, right? Didn't really prove a lot because, you know, it's a small file. So we'll do a little bit bigger file just to make sure that the parallel puts and gets work. So okay, it's a little slower than the Unix file system as we would expect, but we did a put and a get. Nope, that's not a get. Okay, and we proved that the files are the same. So we support the parallel put and get. Okay, what are our next steps? First off, we've basically kind of cloned all of the Unix file system test cases, and instead of running them against Unix file system, we run them against the S3 plugin, and all of them passed. So we're confident that we're in good shape. Did add some more kind of S3 specific tests to it, and we're testing it against all of the backends that the cache S3 was testing. So I think we're in good shape there. Like I said, I want to look at that upload performance and see if I can improve that. There are a couple of legacy S3 features that haven't been implemented or tested. One is the comment separated list for the S3 default host. We're using the same library, so that should work exactly like the Cache S3 plugin. I just haven't tested it yet. Archive naming policy is one that really needs to be implemented. Right now, we're just using consistent naming. The S3FS code actually does support a, what is the other?
Decoupled.
Decoupled, yeah. It does support something similar to decoupled naming policy. I probably could just turn that on, and it probably would work. But it wouldn't do it in the same way that the cache version does. The cache version takes the ID and flips it. I don't know why, but it takes the object ID in the database and flips it and uses that to write to S3. Okay, some people have asked us to enhance the S3 authentication options so that we're not just using a file on the server to authenticate ourselves, like storing it in a database or something. So we'll look into that, try to get feedback on how you want us to do that. And I would assume we'll also roll that into the cache version as well. Now, if you want to do something like a recursive register from a S3 bucket, right now you can register millions of files in about a second because it's not actually registering millions of files. I realized after we were done that that resource op read directory just returns truth or success, I'm sorry. So we need to implement that so that we can do recursive registration. And I started looking at that last week, and that should be implemented within the next week or so. What else? Oh, okay. The last thing is it's not really directly related to S3, but all the work we've done here, we want to roll over into the other object stores so that you can have an option to not use a compound in the cache with the other object stores, like WAS or whatever. Yeah. Any questions?
So I think that's great, getting rid of the cache. What about especially the authentication part for, I guess, both at the later stage of the plugins? Are you going to be using the SDK so that one would just be able to authenticate with what is, I'd call it, just supposed to work when dealing with AWS? Like pretty much every piece of software now uses the SDK, and you just expect it to work if you run on an EC2 instance without any kind of credentials needed to be configured.
So I think what you're asking, like the libraries and everything, we started with S3FS, so we just used whatever they're using. That was kind of a decision so that we could roll this out quickly, and it seems. Yeah, but yes, we can look at changing that in the future. We'll probably end up using some of the cache management that S3FS uses, but maybe rewriting some of our S3 specific operations. Did that answer it?
Yeah, it's especially about the authentication part.
Okay, yeah.
That is what I would expect to be working the same way as with kind of any other library that uses anything related to AWS or most cloud providers, because those authentications free me from having to define any kind of credentials.
Right, okay.
They are just there.
Yeah, we'll definitely look into that.
Yeah, that would be a special case for what we do now, which is speak the S3 protocol to anybody. And so other systems don't use the same SDK. So right now, the lowest common denominator is a key file. We just haven't optimized that for the special case of running it towards Amazon. It should be pretty straightforward. Haven't gotten there yet. Anybody else? I don't believe it. All right. Oh, wait a minute. Uh-oh. Get him, Alan.
Alan, get him.
Sorry, I forgot if you told me this or not, but was this built using the new thread pool?
No.
Could it be?
Probably, although we're
Hackathon?
not creating any threads. So
Oh, I see.
iRODS is creating all the threads. I mean, on the multi-threaded case, it's because we're doing a parallel put or get, so iRODS is creating those threads. We're just kind of reacting. Does that make sense?
Yeah, thanks.
Yeah, he's in the plugin.
Well, actually, let me restate. We're not creating any threads in that instance. Now, S3FS does do some multi-threading, for callbacks and things like that, but I haven't touched that. So I suppose we could use it. I don't know.
All right. Thank you, Justin.
Sure, thanks.